Alright, in this video we're going to look at spheres. Now, if you think about a circle is a flat, two-dimensional object. Well, a sphere is just taking that same definition of a circle and extending it into three dimensions, into space. So, where on a circle, a radius is the distance from the center to a point on the circle, a diameter is the distance from one edge of the circle to another through the center. That same applies to a sphere in space. Okay, so a sphere is the simplest of all solid geometric figures. Geometrically is defined as a surface whose points are all equidistant from a given called the center. The radius is the distance from the center to the surface. So what I'm basically saying here is, if you go to the center of the sphere, to any point on the sphere itself, that's a radius. The diameter is a straight line distance from one part of the sphere to the opposite part of the sphere through the center. So radius and distance mean the same thing as on a sphere as they do for a circle. Now, we don't distinguish lateral area, surface area on a sphere. A sphere is just one surface. So we don't have a lateral area and a surface area, we just have the surface area. And it's two pretty simple formulas that you can use on your formula sheet. Volume is just the amount of space inside a sphere. And again, you have two formulas you can use there. Which formula you use is depending on whether you're given the radius or the diameter. You can really use either one. Okay? So, with that being said, I think we're going to go ahead and we're going to look at an example here. So, it says, find the total surface area and volume of a sphere with a radius of 15 inches. Round your answer to three significant digits. So I'm going to make a quick sketch because a lot of times, ladies and gentlemen, if you don't have a picture, it's good to draw one. And what they said, the radius was 15 inches. So the radius is 15 inches, and if you don't want to use the radius, you want to use the diameter would then be twice that, would be 30 inches, but you can use either one. So let's start here, A, by finding the total surface area. Remember, we don't have lateral area, it's all one surface, so it's just surface area. Well, since you're given the radius, you can really use either formula, again, it doesn't matter, but for a sphere, the surface area is equal to 4 times pi times the radius squared. Okay? So, pretty straightforward. These are not too difficult to do. We're going to take 4 times, and it really doesn't tell us what we have to use for pi, so you can just use the pi button if you want to. I'm going to go ahead and use 3.1416 as we did on the last example, and then take that times 15 squared. And if you do that, you get 2,827 and 44 hundredths, label as square inches. Because remember, this is a surface area. So again, we want to round to three significant digits. Well, if you do that, these are your three digits right here that are significant. So the 7, what that does is that takes that 2 that's in the tens place and makes it a 3, and then you just use 0 as a placeholder. And that would be inches squared. So that's your surface area. Okay? Now volume, since we know the radius, we're going to use 4 pi r cubed, actually 4/3 pi r cubed. So again, you just got to put in 15 for your radius. And I'm going to use 3.1416 that I used on the previous exercise. You can use 3.14 if you want to. And that's times 15 cubed. Well, again, probably what you want to do is you can take 15 cubed times 3.1416 and then use the fraction button on your calculator and multiply it times 4/3. Okay, you do not want to use a decimal for 4/3. Don't use, I believe that'd be 1 1/3, 1.33333, because again, you're going to get a rounding error. Or you could take 15 cubed times 3.1416 times 4, and then divide that by 3. You could also do it that way if you want to. If whatever way you choose to do it, you should get 14,137.2. Now again, it says 3 significant digits, which would be the 1, 4, and the 1. So what happens is that this 3 here does not affect the 1 in the hundreds place. So we're going to go 14,001, and then for the placeholders for the 3 and the 7, we're going to use the zeros. So 14,100 cubic inches, because this is a volume. Okay. Again, really the spheres are not too hard to do. If you do have questions, give me a yell, and then the last video we're just going to actually look at an application problem.